Everybody, and welcome to the tutorial. This tutorial will be a recap for the upcoming midterm exam, and it will essentially cover two parts, the binary numerical systems and the circuits, because these are the parts that I feel are most challenging for you guys. So essentially this tutorial will be two parts. First part will be the binary, will be a recap for all the binary numerical systems, and the second part will be a recap for the circuits, and we're going to cover sheet 3 where we could find these parts. So let's get to it. So the first question here is to convert this number to a decimal number, and we've talked about this before. Let's take this number for example, which is 10 10 10. Okay, so there you go. We've got 3 tens, so 10, 10, 10. And to convert from binary to decimal, all you need to do is to add up all the ones. So again, these are the place values: 1, 2, 4, 8, 16, and 32. And all you need to do is to add up all the ones. This one equals 2, this one equals 8, this one equals 32. To remind you, because the place value for any of these digits equals b to the power of n minus 1. So here this will be 2, 8, 32, and so on and so forth. So 32 plus 8 plus 2, right? 2 plus 8 plus 32. So this number here would be 42. Okay? Excellent. So we're just going to take one example from each, like the hardest example from each category. So let's get to this. Now, how do we convert, how we do the opposite, how do we convert from decimal to binary? Okay, so we're going to take number 13. So let's say converting number 13 to its binary equivalent. So we agreed that we're going to do, here we have the quotient and here we have the remainder. And what you need to do is divide this number by 2, record the quotient here, record the remainder here, and then pass the quotient. Keep doing this till the quotient is less than 2, and then you pass it as a remainder, and then your binary number will be all the numbers from the bottom up. So let's do that. 13 divided by 2 is that would be 6, and then the remainder is 1, because 6 times 2 is 12 plus 1, 13. Pass the quotient here. 6 divided by 2, that would be 3. Remainder is 0. Why 0? Because 3 times 2 equals 6. 3 divided by 2 is 1, and then remainder is 1. Pass it here. Now this is the case where the remainder is less than, the quotient is less than 2. We pass it as a remainder, as I said, and then the number will be all the remainders from the bottom up. So 1, 1, 0, 1. Just to make sure that this is correct, that this is number 13. So we put 1, 2, 4, 8. So 8 and 4, that is 12, and 1. So that indeed equals 13. Okay. So we are done with converting binary to decimal and decimal to binary. Okay. Now, how do we do fractions? So, for example, let's take this one because it looks a little bit hard. So that's 100, 01, 01. Okay. So, let's drag this a little bit up. Okay. So we said 100 and then 01, 01. So we've agreed that the values for these places are 1, 2, 4, because they follow the formula of v equals b to the power of n minus 1. Now here this is half, this one is half, and this is 1/4, and this is 1/8, and this is 1/16. How do I know? Because the values for these places equals base to the power of minus n. So, you know, if you calculate it, this is 1 over 2 over, so this first place is 2, which is base, raised to the power of minus 1, and that would be half, and so on and so forth. So all we need to do for the fractions is add up all the ones as well. So this one here is 1/4 over 1/16. That would be 4. So let's calculate the fraction first. So 1/4, because this one here is 1/4, plus 1 over 16th equals 4 over 16 plus 1 over 16 equals 5 over 16. Okay, and this one here, of course, is 4. So the integer parts of this number. So let's use a calculator to figure out what 5 over 16 is. Here's a calculator. 5 over 16 equals 8333 something. So we'll consider this 8333. Right? We're going to do truncation. This is called truncation, right? Okay, just recapping to make sure I'm correct. So this would be 4 over 16. So 5 over 16. Okay. So we said let's make it A333. So converting this number will be 4. This is going to be 4.8333. That's it. Okay. So this is how you convert fractions. Okay, we want this base 10. Now let's do the opposite. How do we do? So here we converted a binary fraction, right, to its decimal equivalent. Let's do the opposite here. Let's take 15 over 16. Why? Because this looks very complicated. So let's try to do that. Okay, let's drag this a little bit up. So here we've got, we need to convert 15 and 15 over 16 to binary. So first of all, let's start with this with the easy parts. To do 15, again, we'll use the previous algorithm, right? This is the quotient, this is the remainder. So that would be 7, and then remainder 1. 7 goes here. 7 over 2, that would be 3. Remainder 1. 3 over 2, that would be 1. Remainder 1, and then 1 goes here. So 15 indeed is this number. 1, 1, 4 ones. If you want to add them up to make sure, it's going to come up like this. Okay, now 15 over 16. So we're going to have the radix point here, right? And we just need to convert the fraction. So let's figure out in decimal what's 15 over 16 is. So 15 over 16 equals, now I don't want you to be intimidated, right? Because this looks like a huge number, but don't worry. So we're going to convert this number, 9375. So 9375. So let's convert this to binary. So to do that, we're going to have a remainder here, and look, times 2 goes down. Because we'll ask ourselves, is this number above half, equals greater than or equal half? Yes, then we write 1, we subtract half from this number, and then we multiply by 2 to go down. So this number I wrote 1 minus half, sorry, this number minus half equals times 2 equals, and then we write this down here. Okay, so that would be, sorry, okay, so 875, and we do the same algorithm. Is this above half? That's correct. Write 1 here, subtract half, and multiply by 2. So this number minus half equals times 275. Now it gets easy from this point. So here it's going to be 75. Of course, we have a radix point here, or a decimal point. So again, is this above half? Yes, it is. Write 1 here, and then subtract half from this. That would be 0.25. Multiply by 2. That would be 0.5. Same question: does this equal, or is this equal or greater than half? It is equal to half. Write 1, subtract half, and multiply by 2. We reach 0, and then the fraction will be all the numbers from the top down after this decimal, after the radix point. So this is 15 and 15 over 16. This here, 15 and 15 over 16 equals this. Now there's an easier way to convert this, and I encourage you to use it, but I just used the traditional way because you never know what number you will get, which is, if I say this is the radix point and this is half, this is 1/4, this is 1 over 8, sorry, this is 1 over 8, this is 1 over 8, and this is 1 over 16. You will figure out that if I make this denominator 16, so this first one will be 8 over 16, and this second one will be 4 over 16, and this will be 2 over 16, and this one will be 1 over 16. If you add all these numbers up, this is here, this would be 15, right? So just an easier way to figure out that actually 15 is the radical, and binary is this number right here, 15 over 16, right? Just like 15 is this number here to the right. So that is how we do this. So now we have converted binary with fractions to decimal, and the other way around. Okay, so now we go to hexadecimal. How do we convert this number to hexadecimal? We're going to do this number because it's quite large. So let me print the screen right here, and then go here, and then maybe print over it. So drag this a little bit up. There you go. So we need to convert this number here to we need to convert this binary number to hexadecimal. So the way to do this is just to put points after each 4 bits. So sorry, that would be here, here, and here, and here, okay, here, okay, and here, okay. Oh, I made a mistake. So because they have to be multiples of 4, so we're going to do this again. So 4 here, I hope I get it right this time, and then here, and here, and here, and here. I guess I messed up again. 4. Oh, these are 5. Sorry guys, pay more attention this time. Okay, here and here. Sorry, here. Okay, no. Oh yeah, there you go. And then here, and then here, and then here. Yes, I think I got it this time. Yes. Okay. And then all you need to do is turn each of these numbers to its hexadecimal equivalent. So, for example, this is 7. How do I know? Because I'm going to write here 1, 2, 4, 8. So 3 ones, that's 7. So write 7 here. Sorry. Let me drag this a little bit up. Yes. So write 7 here. Okay. Following 4, that's 1. Look, 1, 0, 0. So that's 1. So write 1 here. 1 in. Remember that we from 0 to 9 in decimal is the same as in hexadecimal. So the third 4. So this is 1, 0, 1. So that would be 5. Right, 5 in here. Why? Because 1, 0, 1 here is 4 plus 1 is 5. Okay, so we've done 1, 2, 3. 1, 2, 3. 1, 2, 3. So we are here now. So again, 1, 0, 1. So that's another 5, if I'm not mistaken. And then this number here, 0, 0, 0, 1. That would be 8. So 8. And finally 1, 1, 1, that would be, let's see, 1, oh, I'm sorry. So that's because that final number right there, that final number is 0, 1, 1, 0, oh, sorry, 0, 1, 1, 1, that would be 2, 2 and 8, that would be 14, and we all know that 14 in hexadecimal is E. So that's how to convert this number into binary. E85517. Okay. I hope I am not going so fast. So let's convert from hexadecimal to binary. Okay? And I'm going to take this screen and print it. I'm going to print it right here. Okay. So to convert from hexadecimal to binary, it's the same thing. All we need to do is we take each digit from these digits and then convert it to 4 digits binary. So 7, let's start from here. So 7 would be 1, 1, 1, 0. Okay? And then 9 would be, if you don't want to get confused, you always do this. So 9 would be, oh, sorry. 9 would be like this, right? Because 8 and 1. So 1, 0, 0, 1. Okay, so we've done 7 and 9. D is number 13, guys. So 13 is like this because 8 plus 2, 10. Oh, I made a mistake. 13 is, let me see, that would be oh, I'm sorry. 13 would be 1 here, 8, 1 here, so that would be 12, 0 here, and 1 here, right? Because that's 12 plus 1, 13. So 1, 0, 1, 1, because D is 13. So 1, 0, 1, 1. We're done with D. F is 15, which is 4 ones. 1, 1, 1, 1. And 5 is this number right here. So 101. Now, be careful here because remember that we said they have to be multiples of 4. So you need to add a 0 here. Why? Because when you convert this back to binary, or sorry, when you convert this binary code to decimal, This is how you're going to do it. You're going to put dot here every 4 digits. Dot here, right? And dot here. And this one here, it has to be 4. So see, if we didn't put this, it would have been 3. So you need to add a 0 here. Okay. So how to convert from hexadecimal to decimal? Well, that's pretty easy. So we're going to convert this 6e from decimal to hexadecimal, but I think this video is exceeding 20 minutes, so I'm going to have to finish up here, guys. And we're going to start in the next video. We're going to start from this point. So thank you for watching, and keep watching for first midterm recap part 2. Thank you guys so much.